Hello everyone. Today I'm gonna go through the ARIMA model. ARIMA model is the model used in the time series data. So time series data is the data that is historical data that is associated to the time. So the first value is preceded uh, with the value before it and succeeded with the value that comes after that value. So um, I have already imported the data set. If you want to get the data set, you can leave the comment and or contact me, so I can give you the data set in order if you want to use that data set on your experiments. And I will give you first some descriptive analysis, descriptive statistics of the sales data, sales values of the sales column. So there are the length of the column is 200. The average sales amount is 14. Standard deviation is also dispersion of the data from the mean is 5.2. The minimum sales amount is 1.6, and also we have the quartiles, and the maximum is 27. So as you see, the median is 12. It's so close to the mean, so that means that the our median and mean are so close to each other. That's a good start. So what we're gonna do, we're gonna go through how to choose the three values of the ARIMA model. As you know, the ARIMA is composed by the autoregressive integrated moving average. ARIMA stands for autoregressive integrated moving average. If you want to read about ARIMA, I strongly recommend you to read the books The Principles of the Forecasting. I will leave the link for that book where you can get that book. So it's a really good start if you're doing the MBA and you have chosen you're doing the financial analysis or something else, or you're simply in the market, like whatever thing, like this in this case, like for instance, if you are doing the advertisements, you're a marketing guy or marketing lady, and you want now also your data, the dynamics of your data. So that could be a great start for you. So the ARIMA model is composed by three elements. So the first element in the ARIMA model is the P. It stands for the autoregressive. Then D, integrated, and Q. Q means that the moving average. So how to find these three values and how to associate, like the assign these three parameters in order to get the great results, the best results. So the literature says in order to um, get to the second point, the autoregressive part, first you have to go through the second point, which is integrated integration. And what does it mean? Um, it's simply the prerequisite for passing to the P, and through that we are determining the differencing parameter in ARIMA model. So we need to assess the stationarity of our data set, of our data series, and the way we can do this is the augmented decay Fuller test, aka add Fuller, or ADF. So ADF test, as you see here, we have imported that method, so we can already use that method. In order to use that, it's pretty straightforward. You just write the add filler and you just insert the data that is your interest data that you would love to forecast. And let's see what's happening now, and then we'll go to the. So you got this this attributes of the of as an output, and here what we are interested in is our p-value, which is the first one. I mean the second one. The first means second in the Python, so you know that. So as you see, the p-value is quite small. It's let's convert this to the readable way so we can assess that data round. Let's take 4 digits after to round. Just a second. Here's it. So as you see, it's 0.0, and ADV tests wants you to assess your data, to assess the hypothesis says. The hypothesis says that the data is non-stationary, and by rejecting the null hypothesis, we are um, we are if we are getting below 0.05. Do you remember in the regression the p-value is if it's below 0.04 we are rejecting the hypothesis. So we are saying that the data is stationary. In this case, that means that your base value, baseline is already stationary, so you don't need to do a stationary differentiation. And otherwise, if your data, if your series is not stationary, in that case, you would love to do the differentiation. Like if you want know about the code for that, just ask me for that. I'm gonna provide you how to get the differentiation. And in that case, you're gonna use the differentiation until you get the p-value below 0.05. All right, now this point is clear, so that means this point here is gonna be 0 since there's no the differentiate. There's no the need for differentiation. The second point is p, that is the autoregressive autoregression, right? The autoregressive element component, autoregressive component. Let's call it in the correct way. In order to assess that component, what we're gonna do, we wanna do the partial autocorrelation function. Like we want to use partial autocorrelation function, and the way we are gonna use it is visually. So we have already imported also here the plot PACF, and what we're gonna do now, just simply write plot PACF, our series that we are interested in, and just run it. Hold on, we didn't show the figure, so we should also show the figure. And there's our data. So what we are interpreting here, so just a quick interpretation. Here what you want to do is to find the values that are going out of the this interval. You see this interval? So the spikes, that's how the statisticians are calling that, and the spikes that you're seeing here indicating the what is the p autoregression component should be. So in our case, spike is 20, so we are gonna get the 20. That's what our what our plot says to us. So and there's also another way how we can find that one through the calculations and get the number of the p. In order to do that, we are just just importing the 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 module that's called the stats models TCA models TCA stat tools import PAC fee SV CV. So this is the previous one was the PAC fee plot. This one is the PAC fee without indicating the visible plot. So we are getting the PAC fee values through this code. And next, what we want to do, we want to get the significant lags. That's how we calculate in the confidence interval. I'm just gonna copy and paste this code because it's a little bit long. So what you see here, the PACF values that are greater than 1.96, it's gonna be 95% divided to the number of the observation number of the sample that we have. So we are running this, we run the second one, and then we are gonna have the maximum of 8 significant lags. So this is gonna be basically our p-value, not defined because we have to run that. Significant lags. Where is the so numpy is not defined. Let's import the numpy too. Import numpy as np. Here's our numpy. Let's run again. So our p autoregressive component is 20, as we have seen on the plot before, right? So we are filling this point too, and the last point is remaining here is the Q part. For finding the Q, which is a moving average, the literature says there's a so-called rule 7. It says that if the ACV autocorrelation function of the difference at series displays a sharp cutoff and or the lag -1 autocorrelation is negative. If the series appears slightly over difference, then consider adding a MA term to the model. The lag at which the ACV cuts off is the indicated number of MA terms. That means that wherever we are finding the so first we are gonna plot the ACV autocorrelation function, and then what we are gonna do is to find the first cut off, and that's basically gonna be our that's basically gonna be our Q component, moving average component. So to do so, we are just importing the plot ACV that we already did that, plot ACV. So we are basically gonna do the same that we did with this one, but in this case we are gonna write plot ACV. Right. So it's so similar to our plot that we have plot for the plot PACV, partial autocorrelation function. Here also we have a spike, also the first cutoff, which is on the 20th. Just don't consider this one because it's a 0. It means it's not the lag, it's the value itself. Now, if you're not familiar with the lag concept takes you the previous value that you have on your historical time series data. For instance, the lag of today is yesterday. The lag 2 of today is the day before yesterday, and so on and so forth. Lag 7 is gonna be 7 days before today. Okay. So in this case, we are gonna take also here 20. And it's gonna be 20. And then what we're gonna do, we can run our ARIMA model. We can say ARIMA model is equal to, I'm just gonna copy and paste that one, like I'm lazy to write all of that. Because, come on guys, everybody does that. Everybody copies and pastes from the Stack Overflow. It's not defined. It's not defined because we haven't imported the import stat models as SM. Alright, now we should be okay. Has no attribute. ARIMA. We actually have imported this guy here. Why it's not working so? Let me just try again. Alright. Y train is not defined because before I used the Y train. So let's go one step behind, one step back, and split our data set to train and test subsets. That's what we are doing as a data scientist, splitting data sets to subsets and then bringing back again together and so on. That's basically the data analyst, data scientist job. Yeah. So if you see here, the Y train is basically the 70% of the data, which is getting our sales data. Let me just print it. I'm just printing it out to show you what we have here. So it's basically the sales data. Alright, let's go forward. And that's, they are not using anymore this like this. It says that it's depreciated, right? What does it say? That's a file not implemented error. Stats element stats model have been removed in favor of standard TSA ARIMA model ARIMA. So should we write TSA ARIMA model ARIMA instead? TSA is not defined. Okay. Has not the attribute ARIMA. That's quite bizarre. That's quite bizarre. Let's try this one. I just used this morning this model and it used to work. Now it's not working anymore. Has no attribute ARIMA. Has no attribute ARIMA. How can you not have an attribute of ARIMA that I have used this morning? Why? What's your problem? Okay, let me. Let's do the next copy paste pass on the Stack Overflow and see why it's not working. Why it's not working? So it suggests to use the next. So we already did that. Okay, probably I haven't imported the stats model API. You can just skip this part. It's not fun, I know. Or I will trim this part. Okay, I will find a way to trim this part. How I hate when it happens. Unsupported index has been okay. Unsupported index, so it wants us to have the date as an index. Alright, if you want date, let's create a date and give you like, let's create the date. Let's now create the date. So the problem is that we have the unsupported index was provided. So I'm quite sure that it wants us to have the date as an index. So that's why I'm gonna create the weekly data. So we are gonna suppose that our data is a weekly. So every week we are having the new data. We are gonna associate, just copy paste this one if you want to apply to. We are gonna associate this one, add to our data frame and set this as an index. Alright, here we are creating, let me leave the command, so for the next time we are creating date values to use as an index. We're gonna close this here. Why did I do that? No. And here we are assigning the date. We are setting the date as a index. Now that's the time. Time has came. Okay. Now the next we're seeing what. Okay, we have now the dates as the not eatable dates. Date as an index. No frequency information was provided, so ARIMA model. I'm not interested in the frequency. Okay. In order to see your ARIMA model, finally you're using this summary and printing that summary in order to get your results. Are you ready? It's the same as you're using in the with the linear regression model. So here we are. Um, don't get scared of seeing that. The some stuff that we are interested in here, just looking through the numbers. P-values, for example, here you see that most of them are not statistically significant. The only one is that I'm seeing the statistics is autoregressive component 20. That was actually what we told that is correlated with our current value. And for the rest, we are seeing the AIC is IK information criterion, if I'm not mistaken. Correct me if I'm wrong. So the less it is, the better it is. So you need to get your this one, the AIC, the least possible in order to get the best results. But one thing that I would love to mention is that, as you know, the I don't know, or not. Like, if you don't know, I would inform you that there is a auto ARIMA. This is the model developed by the statisticians, like the by the scholars. Say, let's say that. So it's getting you the best model to estimate, to best model, best parameters. I've used that one, and I got the IAC much more lower, and that was literally 0, 0, 0 intercept, added intercept. So also the literature says you should go through all these steps in order to find the you need to go to assess the stationarity. You need to see like the AC fee and PAC fee and take the values that are over there. Sometimes the auto ARIMA is much more better to use if you want to just if you're confident enough, if you trust the auto ARIMA and you'd want to use that. If you're interested in that too, I can share with you the link. So that's it. Thank you very much, and hope you enjoyed, and you hope that this lecture was useful for you. And see you next time. Bye bye.